All right, here's just a few quick solutions to the warm-up questions that we've had over the week before break. So here's the series circuit that we were looking at. So it's a 9-volt battery attached to first a 3 kilo ohm, then a 10 kilo ohm, then a 5 kilo ohm resistor, all in series. So to solve the series circuit, we look at the total resistance. So you add each of those up. So starting at the top there, the series resistance is the 3 kilo ohms plus the 10 plus the 5, so 18 kilo ohms or 18,000 ohms. The total current is just the voltage divided by the resistance. So you take that 9 volts divided by your 18,000 ohms, so you get 0.0005 amps, which is 0.5 milliamps. And then to find the voltage drop across each resistor, we just use Ohm's law for each resistor. So you take the current, which is the same because they're all the same. They're in series, so they have to get the same current. So you have a voltage set up for the first one, which is just the total current times 3,000 or 1.5. Second one is the total current times 10,000, which is 5 volts. And the third is the total current times 5,000 ohms, which is 2.5 volts. And then if you add all three of those up, you get 9 volts because you have to use the energy supplied by the battery. That's the only way for the circuit to work. So the things to remember about series circuits, they're a little bit simpler than parallel, is the resistances you just add up. The current you just find using Ohm's law with that total resistance. So the only thing you really use the total resistance for is to find the current. And then for each individual resistor, you use Ohm's law, and they all get the same current because they're in series. That's one of the rules. There's nowhere else for the current to go. If I go back here, if 0.005 amps goes through here, it has nowhere else to go but through this next one and then through the next one. So the same current goes through all of them. So each gets their own voltage, their own electric potential difference. And the smaller the resistor, the smaller the voltage. But if you add those up, you get to that total. Now with parallel, the difference is now the currents all have different paths to travel. So the currents are different, but if you look at it, the voltage drop from 0.2 to 0.7 is the same as 0.3 to 0.6 because you're just from the positive side of the battery to the negative side. There's nothing else in the way. So each of those resistors gets the full 9 volts of the battery. So to find the parallel resistance, you add 1 over the individual resistances. So that's 1 over 10,000 plus 1 over 2,000 plus 1 over 1,000, which is 0.0016. I did it with my calculator. I didn't bother with finding common denominators. And then because this is in the denominator, you just have to take the inverse of that. And so I get 1 over 0.0016, which is 625 ohms. Voltages are all the same. They're the same because they're attached in parallel. So then the current, the total current is just the total voltage divided by the total resistance. That's how much goes through the battery. And then you can add up, then you can find the individual current. So through the first resistor, it's 10,000 ohms. So you see that it gets 0.0009 amps. Second one gets 0.0045 amps. And then the third, the 1,000 ohm resistor, gets 0.009 amps. And then if you add up those three currents, strangely enough, they equal the total. So the current all goes through the battery and then splits up through the individual resistors because they each have the same voltage. And that's where all of this comes from. So hopefully that helps a little bit. We're going to look at some compound circuits this week to help you understand a little bit of what's going on in more complicated things.